This is one of the classical Google interview questions. This is being asked in the Google. Okay, most of the time in the technical interview of the Google, this question is repeatedly asked. What is that question? It is edit the distance for converting a text of this into this text. But here the main important thing is the minimum number of operations. That means I want to convert this intention, this is my string s1, and convert to s2, which is executions. In order to convert this text into this text, what all the minimum operations required? When I say operation, for example, let's say I, this is not matching, so I need to replace I with e. This is called a replace character. So the possible operation can be insert, delete, or replace. This is all about the questions. This is Google interview questions. Even though this looks like simple, but after after even though this looks like simple, but this question is filter out 90% of the candidate in the technical interview. So pay attention on this one. Since our intention is to convert this one, proper execution is important. When I say proper execution, is important, don't jump on greedy algorithm. At least don't go on the brute force strategy. Whenever you are going to brute force strategy, that means the complexity will be max. When I say max, all the possible conditions you are going to check. That's why it is called greedy algorithm. The moment you jump on the greedy algorithm, you are directly rejected. Since it is a Google interview questions, they expect the complexity should be minimum. So first we'll see the greedy approach. When I say greedy approach, even though, let's consider this is my last n characters, it is matching, so might be you are going to do a no operations. Since n is matching, the number of operation will be 0. As it is, you are transforming this n into this n. O as it is, I as it is, t as it is, and you can replace. So this is what at current situation, even though it looks like a best choice, but going forward, to convert a complete text from this one to this one, it might not be a best solution. That's why greedy can be best solution. It can be one of the good solution. It cannot be, not necessary it is optimal solution. That's the reason greedy method might get a good solution, but not always. And the last is brute force. Brute force one should not apply. Brute force is just to understand the problem. One should not go for all the combination. When I say brute, that means for every decision you are going to check all the possible solutions, which is 3 solution. With one character I, what will happen if I am inserting a new character, if I am deleting, and if I am replacing. That means for each character there will be 3 choice, and with this 3 choice, what is the result? That's why it is called brute force, and this choice is applicable for every character. That means each and every character you are performing 3 operations and checking whether it is converting this text into this text. That's why we are not going with brute force. Now we'll see for in optimal solutions. When I say optimal solution, can you think of a better solution which can be based on recursion? I will say optimized recursion rather than recursion. This optimized solution can be, if it is based on the recursion, then it can be one part of DP, which is called memorization. When I say memorization, it is optimized recursions. There are 2 ways. I hope you know this one. This DP, why I am thinking to solve this problem with DP is I am not directly jumping on the solution. Rather than that, I will get a small solution. Out of these small solution, which is a best solution I will pick, and this best solution I will utilize for my next decision. That's the reason. If every step, let's consider this is my step 1, step 2, step 3, and it results me a optimized solution that gives me output result. That means every next step depends on the solution of the previous. That's why this DP approach is helpful. DP is one of the ways to solve the problem where every next step depends on its previous step, and that previous step is a good solution. I am taking the good solution to move on the next step. Out of this one, I am going to take the next step based on my previous good solution, and finally I am getting the final output. This is how we can solve this problem using DP. This DP we are going to solve in two ways. One is we call as tabulation, and second is called memorization. Here in tabulation it is we call as bottom up approach. Since we are going to solve a smallest problem, go to the next step and we will utilize this previous solution, and go to the next. Every next step we are going to utilize the best solution of my previous steps. Now let's break this problem into the DP tabulations. When I say DP tabulations, we are going to create a table. Usually we call as DP table because it has one solution, and out of this solution we are going to take a good solution. When I say good solution, which means minimum operations. Now, before jumping on the DP, can we think of the worst case of worst solution? When I say worst case of worst solution, to convert this text into this text, what I can do is I will delete all the characters of this text. How many characters? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 operations I deleted. Then what I can do is insert I, insert and T and E and T I O N. That means additional 9. So it will be having 18 step to convert intention into executions. 9 character I am deleting, which is executions, and then 9 character I am inserting, which is another 9 step. So total step will be 18, which is a worst case of worst solutions. Instead of that, what I am going to do is I am going to create a DP table. Don't think too much on this complexity. We are not directly jumping to solve this one. First, we'll break up into a small. For now, what is DP is I have this text which is S1. I have one more text which is we call as S2. This S1 we want to convert to S2. Now, before converting directly text, first we'll consider each characters one by one characters. Let's consider E, X, okay. String S1, if it can be blank, okay, consider it is blank, and S2 is also blank. To convert S1 of blank to S2 of blank, how many operations we required? So we don't require any operation. S1 is also blank, S2 is also blank, so we don't need any insert, update or delete operation. So this will be having the result 0. We don't need any operations. Let's consider my S1 is blank, S2 is E, which I represent here. Okay, this is my S1, this is my S2. To convert a blank into E character, to convert a blank into E character, what we required? We required to insert, right? Because it is blank, so I will insert E to become E. To convert S1 into S2, we require to insert E. That's the reason number of operation is only one operation, which is insert operation. Can you see here the insert operation is from blank to E, right? So from blank to E, it will be one operations. Now, same way can we proceed with blank to E and X. Consider I have S1 E blank, S2 is EX. Now, to convert a blank to EX, how many operations required? Insert E and insert X. That's why insert E is one operation, insert X is second operation. So it will be having two operations required. In the same way, to convert a blank into execution, how many operations we required? Insert E, insert X, insert E, insert C, U, T, I, O, N. So total 9 operations required for each character insertion. That's why the first row will be having incremental series of numbers based on the length of the S2 string. This table represent to convert a space into execution, we required how many operations? 9 operations. So every move from this cell to this cell is what kind of operation it is? Insert. It is a insert operations. This arrow mark represent insert. Now consider this one. S1 is blank, S2 also blank, we required 0. Now let's consider S1 is I convert to blank. This is what I represent. Okay, this is my S1, this is my S2. Convert an I into a blank. That means I should delete I. So this represent a delete operations. To convert I into blank, we are going to delete, which is one delete operations. So this arrow represent delete. I hope this you understand what is the arrow mark. If I go like this, it will be insert. This will be a delete operations. With this fundamental, we are going to solve for all the combinations. With I combinations, how I can convert to this one. With IN combinations, how I can convert to this one. With INT combinations, how we can convert to this text. This is what represent a progressive solution. When I say progressive solution, considering each character and each combination, I am going to check for the solutions. Now, this is the crux of these algorithms. Consider I have the text which is S1. S1 is INTE and S2 is, let me write, this is my S2, this is my S1. I want to convert S1 into S2 text. First, blank to blank, how many operations we required? No, we don't require any operations, so I will mark as 0. Now, blank to E, how many operations required? I have the text which is a blank text. S1 is blank, S2 I convert to E. In order to convert a blank into E, how many operations required? We required one insert operations. So this is one operations. So if I am marking like this directions, that indicates that I am going to insert a character which was not present in S1. That's why I am inserting E to become the S2. Now consider I have the text of I in S1. I convert to a blank. Now S1 will be having I convert to blank. This is my S1. This is I want to convert to blank. What I need to do to convert I into blank is a delete operations. This delete operations I will mark as down arrow. So this is one operation required. This is how the DP table will be populated. Now proceed. Okay, now I have S1 with I and N. Now I will be having I and N. I want to convert this IN into blank. How many operations required? I need to delete this one. I need to delete this one. Total two operations. For I, we know already the result, which is 1. So this I will be deleting again, and I will be deleting. So it will be having two operations. In the same way, can we proceed to convert this text into blank? Now, since we need to convert complete text into blank, I will be deleting one by one character. So this will be 2. I will delete T, it will be 3. I will delete E, this will be 4 operations. This represent S1. I want to convert to blank. I required 4 operation, which is a delete operation. This represent delete. So this down arrow I will say remove operations. I hope you understand this table at least. Okay, this text I will convert to a blank. This text I will convert to a blank. I required 4 operations. Now once we go through this one, then I will consider I and E. So this is my S1, this is my S2. How I can convert a text of I into E? I into E, which is this table. Okay, this how we can do I into E. I will, since I is different, E is different, I need to replace I with E. This is different. I and E are different. I need to replace. So what I can say is I will replace. Replace means this arrow 0 with 1. So it was 0. I will say replace with 1. Since I is not matching with E, so I will increment. If it was matching, let's consider this and this one. Yes, it is matching. I don't require any operation for converting E into E. Here, whatever value was there, I will keep as it is. I will not increment with plus 1. I will not do this one. Since E and this E is matching, so what I can say is, if both the character is matching, I will copy as it is. This will be as it is text. So I will say 3 as it is. Otherwise, what we can do is take the operations, which is replace, remove and insert, whichever is minimum out of these 3. Take that minimum operation plus 1. So I will go with the next step, because every operation we required plus 1 operations. Since we are going to perform the operations, C1 is not equals to C2. So we are performing the operation, that's why we are incrementing with plus 1. With which value? Minimum value, either of this one or this one or this one. That's why it is called best solution. We are populating the DP table with a minimum best solution, minimum operation, and I will go ahead with the next step, which is plus 1. If in case C1 is not matching, if C1 is matching with C2 here, so I will do just copy the same thing, because it is matching, this is also matching, so I will move with as it is this steps. So in order to convert E and TE into E, how many operations we required? 3 operations. What is that 3 operations? Delete I, delete N, delete T, then keep as it is E, which is I'm not going to do plus 1. So as it is, I'm taking the values. Only this 3 is for deletion of I N and T. Rest E is matching with E. I will keep as it is. This is all about this operation, which is a diagonal. Diagonal means replace. In case if C1 is not matching with C2. If both are matching, as it is, copy the values which was there on the diagonal top window. Now, every operation, remember, we are going to take these three values into consideration, take the minimum values and do the next operation. If both are matching, take the value as it is, which is on the diagonal window, which is like this. So with this one, we are clear. If like this arrow, that means we are removing a character. If this is the arrow, that means we are doing insert operation. If this is the arrow, that means we are replacing the character, this with this. Let me write this one. Since this is N, this is E, so what will be the value on this DP cell? It will be plus 1. So this value plus 1, it will be 2 value. With T and E, yes, I'm going to replace, so it can be a third operations. Now, even though I can go with the step from like this, if I go like this, okay, consider I am going to replace I with E. This replace 1, 2, 3. Then since I already replace I with E with one operation, it will be two operation, which is delete operations. Again it will be delete operations. Now this E I need to delete, so it will be 4 operation if I follow this path, right? Instead of that, what I can do is I can follow this path and go this path. So what I'm going to do, delete I, delete N, second operation, delete T, third operations, keep E as it is. So within third operation, I'm going to convert a text of INTE into E. If I replace I with E, it will be 4 operations. If I replace I with E, it will be 4 operation. Otherwise, if I say delete this one, delete this one, delete this one and E as it is, it will be 3 operation. That's how we should follow which path? This path. It will be 3 operations. With this understanding, can we move ahead with the actual solution? What is that actual solution? Convert this text into this text and gradually we are going to build the DP table. Now we'll go one by one very quickly. Consider this is my blank to blank. How many operations we required? 0. Blank to E, we required one operation. What is that operation? It is right arrow. That means it is an insert operations. So I need to insert E. Now blank to EX, how many operations we required? 2 operation. Insert E, insert X. In the same way, insert E, it will convert EXC, right? Blank into EXC, we required 1, 2, 3. What is that operation? Insert E, insert X, insert E. In the same way, to convert a blank into E execution, we required 9 operation. All 9 operation will be insert, insert, insert till I reach N and insert. It will be required 9 operations. Now, I hope the first row is clear. Now, this is blank. How we can convert an intention into blank is I need to delete I. So I into blank is delete I, which is one operation. How we can convert IN into blank is delete I and delete N. So it will convert IN into blank, to delete operations. In the same way, to convert an intention into blank, we required delete I, delete N, T, Ention. All are top to bottom this arrow, okay, down arrow. That means it is a delete operations. So we required 9 delete operations to convert this intention into blank. So this row is clear, we are performing delete operations. This row is clear, we are performing insert operation to convert a blank into execution. That's the reason the first line of the program is initialize everything with 0, then convert the first row to the length till the length of the text, and this also convert to length of this s1. Now next next step is very important. Now we are considering I and E. That means this solution we required. So what is this solution? This solution is the best solution out of these three values. What is these three values? One is this is remove, this is insert, this is replace. In case this is not matching, this is not matching, E and I is not matching, that means it is a replace operation. What we are going to replace? I with E. That's the reason I have taken this arrow as 0 to 1. We are performing plus 1. I hope you remember this concept. In case if it is not matching, replace is one operation, that's why we are adding 1. If both are same, then as it is, we should not increment the values. Whatever the values is there on this window, we need to copy that values. Now so far we are good with this values. So this was 0, I will take minimum value which is 0 out of these three values. This 0 is minimum, I need to replace, that's why I with E, which is plus 1 operations. Now I will take this part. This part is how I can convert I into EX. What is that? So to convert I into EX, what we can perform is, let's consider first thing, this we already replace I with E, I with E. Now what remaining to convert I into EX is insert X, because already we replace I with E, so we need additional X, which is insert operation. That's the reason this is a right arrow. Right arrow is insert operations. So after replacing I with E, which is this one, I'm going to insert which character? X. So optimal solution for this one is 2. Now this was 1, okay, plus 1 it is 2. In the same way, how we can convert I into EXE? Yes, we replace I, insert X, insert E. That's the reason I have 3 operations. Now EXEC, yes, it requires 4 operation. How? This 3 plus 1 is 4. 4 plus 1 is 5 to convert to this one, to convert to this one. Now the most important is I, because I want to convert I to EXECUTI. Up to this point we are going to find out the solution of this one. Since this character I is matching with I, do you see the arrow mark here? Since this character is matching with I, so I'm going to not increment. Instead of incrementing as it is, I'm taking this value. Till this operation we required 6, right? So to replace I with I, we don't need any operation. We don't need to increment the values. As it is, we are going to take 6. What will happen if I say this direction? No, it is not an insert operation, so I should take this value, even though both are same values, but minimum is this value we have to take. After T, we should not replace, insert or delete. As it is, I will keep as it is, so it will be 6 operations. Rest of the things, yes, to convert to this text, Yes, additional one character insert. What is that one character insert? Which is O. I as it is. O I'm going to insert. So this insert will be a right arrow. For up to n, it will be one more insert n. Now let's proceed. This part is done. Now the S1 is I and N. With this I and N, let me highlight this one. Okay, this is my I and N. I want to convert to this text. Okay, this is my S1 fixed value. I'm going to populate this row. First IN to blank, one delete, second delete. So I required two operations. IN to E to this one. What I can do is, first I will replace I with E, which is one operations. This is what we call as a replace. Then since I want to convert to E, I will delete N. That's why it is down arrow. Down arrow means delete. So this one plus one operation, it will be two operations. With this IN, I want to convert to now EX, which is this one. Now pay attention on this box. First thing is delete, replace. I can say this is replace I with E, which is one operation. Again replace N with X. So this character is not matching with this character, even though this is diagonal operation, which is replace, but we have to do plus one. Replace E, this is what, and this is replace N with X. So it will be having two operations. Now this N I keep on adding. Okay, EXC. EXC means yes, we deleted EX, but we need to insert E. That's why it is plus 1, it is 3. Again plus 1, it is C. Plus 1 U, plus 1 T, plus 1 7, plus 1 I 7, plus O 8. Now pay attention on the last one. To convert a text IN into execution, what is the next step? Yes, up to this one, yes, inserting O, but here this character is matching with N. So what I'm going to do is, as it is value, I will not increment the values because N is matching with N. I don't require any operations, so minimum operation is 7 operations. I hope you understand up to this part. Now, shall we proceed with the next step? Instead of IN, now I will take IN and T. Now, this INT I want to convert to blank. I hope this we already knows we require three operations. What is those three operations? Delete, delete, and delete T. Once we delete I and T, it will convert to blank. This is what converting this INT into blank, we require three operations. Now pay attention on this one. How we can convert I and T into E, which is this one. How we can convert? We can do this path. I replace with E. This is what diagonal operation, replace. Since it is not matching, this is one operation. Then what I can do is delete N and delete T. So if I delete this one, this already replaced with E, so we required three operations. This is one thing, right? Yeah. Now in the same way, yes, we all EX, E and T we want to convert to EXC. How many operations we required? Three operations. We already replace, and replace. This is what. Now we will proceed till this position. So this is very important because this T is matching with this T. So we are going to insert, but here, since, pay attention on this one, till this position we required 5 operations, but here we don't require any operation because this T is matching with this T. That means this I will take as it is. I will not increment the values. This is what we call if the character is matching. So we required 5 operations to convert a text int into excu. So rest of the things, yes, we required insert I, insert O, insert N. So I keep on incrementing. This is what insert operations. So this is the final solution to convert int into execution. We required minimum how many operations? 8 operations. In the same way we need to proceed. Okay, yes, to blank we required 4 operation, which is delete operations: 1 delete, 2 delete and 3 delete. Now pay attention on this one. Since this is also this is also to convert a text, let me highlight inte into e. How many operations we required? We required 3 operation if we follow this path. If we follow this path, then we required 4 operations. So that's the reason I highlighted this one. Okay, now we'll pay attention. If we go with this path, what the operation we are performing, and if we follow this path, what the operation we are performing. Now pay attention on this part. We are converting inte into e. First thing what I am going to do is delete and delete t. Then after deleting the t, this arrow mark, what does this represent? This arrow mark represent as it is. Since this e is matching with this e, I am not going to increment. As it is, this 3 operation I am taking. So E, I will not do any operation. Not the delete, not the insert, not the replace. Keep as it is. This one, keep as it is means we are not going to increment any operations. So this is 3 operation. What all those 3 operation with this part? Delete I, delete N, delete T, keep as it is E. That's the reason it is 3. I hope this path you are clear. Now, the same thing we can do with this path as well. Let's say, what is this operation? Since this I and E is not matching, it is plus 1. Plus 1 means replace I with E. That's the reason it is plus 1. Now, we already replace I with E. Yes, we got E. What I need to do? Delete N, delete T and delete E as well, because we already replaced this E with I here. That means it is 1 operation, 2 operation, 3 operation and it is going to be 4 operation. What is that 4 operation? Delete E, because we already convert this I with E here. We don't require the last E. So if we follow this path, it will be 4 operation. If we follow this path, it will be 3 operation. That's the reason I mentioned these values. Always while populating the DP table, always take the minimum value of these 3 boxes. What all those 3 boxes? One is delete operations, replace or keep as it is operation, and this is insert operation. Even though if I follow this path, this 3, but if we take this 3, I need to delete E character. If we take this 3, I don't require any operation, so it will be minimum operation. This is very critical point where I need to take the decision the best out of this 3 and this 3. Even though this is also 3 operation, but it is additional delete E, it will be 4 operation if I follow this path. If I go with this path, I already deleted this one, I and T. I will keep as it is E. So it is no more operation, it will be 3 operation. I should follow this path rather than this path. So with this one, we will proceed fast. Okay. Now directly I will jump on O. Let's consider I have the text. What is that text? Till O. Till O. Okay. With this O, I want to convert to blank. How many operations required? 8 operation, which is delete I, delete N, delete T I keep on incrementing. Can you observe this one? This delete E and delete T, delete I, delete O, it will be finally blank. All these things will be I am deleting to convert INTENTIO to blank. We required 8 operations. Now pay attention on this box. How we can convert this text into E. How we can convert? We have options. Okay, either we can convert this into E, okay, this blank into E. This is one operations from this one now, or I with E, this is replace. Okay, this is 2, this is 3, this is 4, because we already replaced 4, 5, 6 and 7 operations. Now if you go with this path, this O, okay, I am deleting everything. Okay, and if I follow this path, then I need to replace O with E, which is plus 1 operation. It will be 8. If I follow this path, it will be 7 operation, because I replace already I with E. Consider I am going to follow this path. Okay, since this is 3 operations, E is having the same E, so I will not increment this one. I will follow this path. Okay, this path, then I will follow delete N, delete T, delete I, delete O. That means if I follow this path, it will be 7 operation. This path, it will be 7 operation. If I follow this path, it is 4th operation, this is 5th, 6, 7, 8 operation. So this is not going to be best solution. So every DP is progressive solutions. We are getting a good solution based on the previous step. We should not take this value, we should follow this path, because it is taking 3. Then with this minimum value, I am going to proceed with delete N, delete T, delete I, delete O. It will be 7 operations. Now since this was O, pay attention on this O. So I'm talking about these values. Okay, how many values we required? We need to just copy as it is, because this O is matching with this O. I should not increment with plus 1. So we required 5 operations. Now the last one, which is N. So this intention I'm going to convert to this intention. How many operations we required? This is 9 operations. Okay, and with E, can you see here E? Yes, it is not matching. So not matching means which operations we required? Blank. Okay, 9. Out of this one, minimum was 7, so I need to delete N, so it will be 8 operations. Now out of this one, 7, 7, which operations we required? EX. This one, EX convert to executions, we required 8 operations. Again, this is minimum 7 plus 1 8, 7 plus 1 8, 7 plus 1 8, 7 plus 6 plus 1. I need to follow this path, right? 6 plus 1, it is 7. Now out of this one 7, you need to check whether this path is correct or this path is correct, because N is not matching with I, so I will follow this path, which is 6 plus 1 7. Now this 5, I need to follow this path. Now after 5, I need to what? Delete N to convert to this portion, up to this portions. Now final is N. This N is matching with this N, so whatever the value is there, I will copy. So final answer is, with this text, how many operations we required? 5 operations. Let me write this one. Intention. The first text was intention, and the second was execution. Execution. Okay, what all the operations we can perform is, first thing is we are going to replace. This is replace, which is one operation. This is also replaced. This is two operations. Then this t is there. So this t I will delete. So this is my third operations. Delete operation. Keep as it is. This is keeping as it is. So I will say as it is as fourth operations. Now 1 2 3 4 execution. Okay, I with this one and with x, deleting t, third operations. This e is as it is. So shall we increment these operations? We don't require to increment. So what I can do is, even though I am keeping as it is, I will not increment any operation. So it will be no operation because e I am keeping as it is. Now next is execution. So I will replace n with c. It is going to be replace operation. Replace is fourth operation. Execution. So what I can do is one more operation, which is replace r with, no, we are not going to replace. So what I can do is, this is insert operation. Insert u, which is fifth operation. Now pay attention on this one. This t as it is, I as it is, o as it is, n as it is. So no more increment. So total we required 5 operation. What all those operations? Replace, delete this one, keep as it is, replace, and then insert operation. This as it is, as it is, as it is. So we required total 5 operation, which we mimic in the DP table. So this is the best way we can follow to get to convert intention into executions. So let me recap. What is that? We can perform 4 operations. If the character is not matching, then we have to do +1. That means we are going to replace. And this arrow mark represent a remove. This arrow mark represent insert. This arrow mark represent a replace. And the next step, since we are going to take the minimum value out of these things and moving ahead. Moving ahead means we are performing some operation, which is +1. If both the characters are matching, then as it is we are taking the value. We are not going to increment any values. So this is remove operation, replace operation, insert operation. Take the best value out of these 3 cells to move to this cell. So what is that? It is an insert operation. This is delete operation. This is replace operations. This is how we can solve the problems. Let me jump on the coding part. How we can perform the coding for minimum edit distance. First thing is we have to initialize a DP array. Since we are initializing a two-dimensional, so I will mark as square bracket with what value we are going to initialize with 0 values. Okay, and how many rows and column for n plus 1. Since we have taken a blank value, which is the base condition, that's why I am incrementing with +1. And this operation I will perform for the range of all the rows. How many rows are there? M plus 1, because I have taken the blank values. And this should not be a square bracket. This should be a curly brackets, right? Now, since I am not going to utilize the variable, so I will mark as blank. Now, the first thing, which is the first row and column, what is that? First row will be incrementing the values. First column will be incrementing the values for blank. Now, for that, what I can do is I will say I will iterate into for loop, okay, for all I in the range of m plus 1. I will initialize the dp of I with column 0 with what value? I value. In the same way, I will convert the first row j in range with n plus 1. This should be colon. And what value I can initialize? dp with 0 row with all the columns j initialize with j. This is the first row initialization and first column initialization. Now I need two for loop. For I will start with m with 1 m plus 1. Since the 0 value we knows the values, and j with 1 to n plus 1, what we can do is only two operation. What all those two operation? If it is matching or if it is not matching. So if it is matching, let's consider if word 1 is word 1 of I minus 1 is matching with word 2 of j minus 1, then if it is matching, then as it is copy, we have to copy dp of I and j by what values? dp of I minus 1 j minus 1. This is what we are copying. Let's consider this is copying. So if I copy, let's say this is copy, right? Because it is matching. This e is matching with this e as it is. This value ij is depends on I minus 1 and j minus 1. What is the coordination of this one? I minus 1 and j minus 1. That's why I of j value will be as it is of I minus 1 and j minus 1. If it is not matching, then I will say else. This is very important. If I say else, then we have to take a minimum value of I j minus 1, which is what is that? J minus 1 means insert, which is a previous column. This is insert column, or we can say I minus 1 and j. I minus 1 and j is a delete operation, which is down arrow. In the same way, we have to take a replace. Replace means I minus 1 and j minus 1. Out of these minimum value, then you have to do plus 1. Finally, return dp of m comma n. So this is the final value where the minimum operation will be required to convert a text from s1 to s2. So practice is very important. Unless and until you practice, will not be able to understand when it is matching, as it is copies the I minus 1 and j minus 1. Otherwise, take the minimum value of insert, delete and replace and perform plus 1 operation, because it is an extra operation. Finally, return whatever the value is there at m and n position. M and n position. What is that? Till the last position, which is 5. This is m and n positions. Since we started with blank, so we are not going to consider minus 1. With m, m is the length of the first and second, n is the second length. This is the last coordination we are going to return that indicates the minimum operations.